So far, we've looked at integrating 6 different types of algebraic fractions. Today is video 7. We're going to look at integrals that look like this. So integrals that look something like this, where you've got one term at the bottom, one x term, and then you have a combination of different x terms on the top. So we've done all these examples in the previous videos. So dividing by a linear factor, dividing by a quadratic factor. Let's look at an example like this. So let's say you had a question that looks something like that. How would you deal with this? Well, with these types of integrals, all you want to do is split this fraction into 4 separate terms. So this divided by that, this divided by that, this divided by that, this divided by that. And so we end up with something looking like this. Now we can simplify the indices using rules of indices. So the first one here, x to the power 3 over 2, divided by x to the power 3. Remember, we subtract the powers when we divide indices. So 3 over 2, take away 3. That's going to give us minus 1.5, so minus 3 over 2. So the first term is going to be a quarter, and then x to the power of minus 3 over 2. Now, the second term, we've got minus 3/4 this time. And then x to the power of 7 divided by x to the power 3. That's going to be x to the power of 4. Now, the next one here, we've got a power of minus 3 over 2. Minus 3 over 2 take away 3. So that's minus 1.5 take away 3. That's minus 4.5. So minus 9 over 2. So we've got a quarter. And then x to the power of minus 9 over 2. So there should be a 2 there. And then the last one, so we've got 10 over 4, which is 5 over 2. So 5 over 2. And then x to the power of negative 3, minus 3 there. So now we can go ahead and do year 1, year 12 integration, add 1 to the power, divide by the new power. So with the first one here, we're going to get x to the power of minus a half, divide that by minus a half. Next, we're going to get x to the power of 5, divide by 5. Next, we're going to get, so quarter, x to the power of minus 7 over 2 this time, divide by minus 7 over 2. And then with the last one, we're going to get 5 over 2, x to the power of minus 2, divide by minus 2, and then plus c. So this here is going to simplify to negative a half, so negative half x to the minus half. Then this one is going to be, so negative 3 over 4 divided by 5, that's negative 3 over 20, and then x to the power of 5. Next one here, quarter divided by minus 7 over 2. That's the same as a quarter times by minus 2 over 7. So that is going to be 2, well, minus 2 over 28. So minus 1 over 14 for this one. And then x to the power of minus 7 over 2. And then lastly, this one is going to be minus 5 over 4, x to the minus 2. And then plus c, and that's our answer there. I mean, you could write that as 1 over square root of x there. You could write this as 1 over x squared. Doesn't really matter. That's our final answer there. Now, another example of this, just to show you how this would work, would be something like this. Now, to deal with this, you do exactly as what we did with the previous example. Firstly, expand the brackets, and then you get a collection of terms on the top. So let's expand the brackets. So I've expanded the brackets very quickly just using a binomial expansion. So 8x cubed, take away 12x squared, plus 6x, take away 1. So then we get something like this, and we just multiply all those terms by 2. So now again, we can split this up into 4 separate fractions. So something looking like this. I'm now just going to simplify everything. So 16 over 3x squared there. We've got 24 over 3, which is minus 8. So minus 8x there. We've got 12x over 3x. So that's just going to be positive 4. And then we've got minus 2 over 3x there. So now we can integrate. So integrating the first term, add 1 to the power, divide by the new power. We'll get 16 over 9x cubed. With the next one, we should get 4x squared. With the next one, we should get minus 4x. And then with this, sorry, plus sign, sorry, my bad, plus sign there. And then with this one, we're going to get minus 2 over 3. And then remember, when you integrate 1 over x, so remember this term here is just 2 over 3 times by 1 over x. When you integrate 1 over x, what do you get? You get ln modulus of x there, and then plus c. So with that one, that would be our answer there. So for video 8 in this series tomorrow, I want to look at examples that look something like this. So an example where you've got some kind of power term plus a constant on the bottom, and then another kind of power term on the top. We're going to do examples like that for video 8 tomorrow, so definitely stay tuned for that one.